Preparing for a SRE at Vercel interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define and choose SLIs, SLOs, and SLAs for Vercel's deployment platform? I would begin with user-visible outcomes rather than infrastructure metrics. For deployments, useful SLIs include successful build completion, time to first response, request error rate, and regional availability. I would set SLOs from customer expectations, such as 99.9% successful deployments, then use the error budget to balance feature velocity against reliability work. An SLA may add contractual consequences, while the SLO guides engineering. I would review objectives regularly as traffic, architecture, and product expectations change. While answering, distinguish SLIs, SLOs, and SLAs. Discuss availability, latency, correctness, and deployment success. Explain user journeys, error budgets, percentile targets, measurement boundaries, and how objectives influence release decisions. Question 2. A Vercel customer reports intermittent 5xx errors from an edge deployment. How would you investigate? First, I would confirm scope using error rate, affected regions, routes, runtimes, and timestamps. I would correlate requests through edge, function, and origin logs, then compare healthy and failing regions. Recent deployments, dependency changes, timeout patterns, and platform health events become primary hypotheses. I would mitigate quickly by rolling back or shifting traffic if safe, while preserving evidence. After recovery, I would identify the root cause, communicate clearly, and add a regression monitor. Make sure to cover incident triage, request correlation IDs, logs, traces, metrics, regional comparison, recent deployments, rollback criteria, customer communication, and separating application failures from platform, network, or dependency failures. Question 3. How would you design observability for serverless and edge functions running at Vercel scale? I would standardize structured events containing request, deployment, region, route, status, duration, and correlation identifiers. Metrics should capture request volume, error rate, saturation, cold starts, and P50, P95, and P99 latency. Traces should connect edge routing, functions, and downstream services, with adaptive sampling to control cost. I would avoid sensitive payloads and uncontrolled cardinality. Dashboards should answer operational questions quickly, while alerts focus on user-impacting symptoms and meaningful causes. In your answer, talk about structured logs, metrics, distributed tracing, high cardinality controls, cold starts, tail latency, sampling, privacy, correlation IDs, platform versus application ownership, and actionable alert design. Question 4. How would you establish an incident response process for a globally distributed Vercel service? I would define severity based on customer impact, duration, and geographic scope, then assign an incident commander, operations-led, communications-led, and subject matter experts. The first objective is containment, such as rollback, traffic shifting, or disabling a risky feature. Updates should state impact, actions, and next checkpoint without speculation. Afterward, I would hold a blameless review, document contributing factors, assign owners and deadlines, and verify that follow-up work reduces recurrence. Be sure to mention severity levels, incident command, clear roles, escalation paths, mitigation before diagnosis, status updates, runbooks, stakeholder communication, customer impact, and blameless post-incident learning. Question 5. What would you include in a safe deployment and rollback strategy for Vercel's control plane? I would build immutable artifacts, validate them in staging, and release progressively by percentage, region, or internal cohort. Automated checks should evaluate availability, latency, error budgets, queue health, and key workflows rather than only process health. Feature flags provide independent control, while backward-compatible database changes prevent rollback traps. If indicators breach thresholds, the system should halt or revert automatically. I would preserve deployment metadata so responders can correlate regressions with exact changes. Focus on canary releases, immutable artifacts, progressive rollout, health checks, feature flags, schema compatibility, automated rollback, deployment freezes, blast radius reduction, and validating both technical and customer-facing signals. Question 6. How would you troubleshoot a sudden increase in P99 latency across Vercel's edge network? I would first segment P99 latency by region, route, runtime, deployment, cache status, and dependency. A trace waterfall can reveal whether time is spent in edge routing, a cold start, origin processing, or an upstream call. I would check saturation, queue depth, cache hit ratio, DNS behavior, and recent configuration changes. Mitigations might include restoring a prior deployment, increasing capacity, bypassing an unhealthy dependency, or adjusting routing. I would avoid masking the problem with broad timeout increases. Discuss distinguishing application from infrastructure latency, regional and route segmentation, queuing, cold starts, cache misses, DNS, upstream dependencies, traces, saturation, recent changes, and mitigation options. Question 7. What is an error budget, and how would you use it at Vercel? An error budget is the amount of unreliability permitted by an SLO during a period. If availability is 99.9% monthly, the budget is roughly 43 minutes of failed service. I would track consumption and burn rate, not merely monthly totals. Fast budget depletion can pause risky releases, trigger investigation, or prioritize capacity and automation work. The policy should be explicit, with exceptions for urgent security fixes. This turns reliability into a shared engineering trade-off. Explain the relationship between SLOs and allowed failure, burn rate, release governance, reliability investment, product prioritization, and exceptions for security or critical fixes. Question 8. How would you reduce operational toil for an SRE team supporting Vercel customers? I would inventory recurring tickets, manual deployments, noisy alerts, and repetitive remediation, then rank them by frequency and risk. High-value improvements could include self-service diagnostics, automated rollback, standardized runbooks, and tooling that gathers logs and deployment context automatically. I would encode safe defaults and require approvals for high-impact actions. Success means fewer manual hours, faster recovery, and fewer repeat incidents. I would measure outcomes after launch instead of assuming automation is beneficial. Mention measuring repetitive work, automation, self-service tooling, runbooks, safe defaults, alert tuning, ownership boundaries, batch remediation, and verifying that automation reduces incidents rather than hiding them. Question 9. How would you design a multi-region failover strategy for a Vercel service? I would prefer active-active operation where workloads and data semantics allow it, because it improves utilization and reduces recovery time. Global routing would use health signals based on real user workflows, not only process liveness. Stateful components require a deliberate consistency model, replication strategy, and bounded recovery point objective. Each region needs spare capacity and dependency independence. I would test regional evacuation regularly, including partial failures, because untested failover often creates a second outage. Cover active-active versus active-passive, health checks, traffic steering, state replication, consistency, DNS or edge routing, failover timing, capacity reservations, recovery testing, and avoiding cascading failures. Question 10. What is the difference between liveness, readiness, and startup probes, and when can probes cause an outage? A startup probe gives a slow application time to initialize. A readiness probe decides whether it should receive traffic, while a liveness probe determines whether restarting it may help. I keep liveness shallow, checking whether the process can make progress, not whether every dependency is healthy. If liveness depends on a database outage can restart every instance and amplify failure. Readiness should remove unhealthy instances, with conservative thresholds and graceful shutdown. In your answer, define each probe, explain dependency checks, startup behavior, restart storms, false positives, graceful degradation, timeout thresholds, and why liveness should remain shallow. Question 11. How would you investigate and prevent a cache-related outage involving CDN or edge caching? I would inspect cache keys, response headers, TTLs, invalidation events, hit ratio, and whether personalized data is accidentally shared. A bad key can serve one tenant's response to another, while a purge storm can overload the origin. I would mitigate by disabling problematic caching, purging narrowly, or serving known safe stale content. Prevention includes versioned assets, explicit cache policies, authorization-aware keys, purge safeguards, and alerts for unusual hit ratios or origin traffic. Be sure to discuss cache keys, TTLs, invalidation, stale content, cache poisoning, headers, deployment versioning, origin load, purge safety, observability, and balancing freshness against performance. Question 12. How would you capacity plan a serverless platform with unpredictable traffic spikes? I would model requests, execution duration, concurrency, regional distribution, and burst patterns rather than relying on average throughput. Load tests should include cold starts and dependency limits, because downstream systems often fail before compute does. Autoscaling needs headroom, rate limits, admission control, and per-tenant quotas to protect shared capacity. I would track saturation and queuing, then pre-warm or reserve capacity for predictable events. Capacity plans should include failure scenarios and cost constraints. Discuss demand modeling, concurrency, quotas, cold starts, downstream bottlenecks, burst capacity, load testing, queuing, admission control, autoscaling signals, and protecting shared infrastructure. Question 13. What strategies would you use to protect Vercel services from cascading failures? Cascades usually begin when slow dependencies consume all available workers. I would enforce short, budgeted timeouts, bounded retries with jitter, circuit breakers, and bulkheads between tenants or workloads. Rate limits and load shedding protect critical paths, while queues absorb acceptable asynchronous work. Fallbacks should be explicit and safe, never silently serving corrupt data. I would monitor saturation and dependency health together, because increasing retries during an outage can make recovery dramatically worse. Focus on timeouts, bounded retries, exponential backoff with jitter, circuit breakers, bulkheads, rate limits, load shedding, queues, dependency budgets, and graceful degradation. Question 14. How would you handle a database migration in a high-availability Vercel service? I would use an expand and contract process. First, add compatible schema elements without removing old ones. Then deploy code that can read both versions and gradually writes the new representation. After validating data parity, I would switch reads, monitor performance and errors, and only later remove legacy fields. I would avoid long locks through online migration tools, maintain backups, and define recovery procedures. Database rollback is often difficult, so compatibility matters more than simply reverting application code. Mention expand and contract migrations, backward compatibility, online schema changes, dual reads or writes, validation, rollback limitations, locking, backups, observability, and staged cleanup. Question 15. How would you secure an SRE platform that manages customer deployments and production infrastructure? I would apply least privilege with separate identities for humans, services, and deployment stages, using short-lived credentials and strong authentication. Secrets belong in a managed store, never logs or source repositories. Tenant boundaries must be enforced in authorization, compute, storage, and observability paths. I would log administrative actions immutably, review unusual access, scan artifacts and dependencies, and maintain a controlled break glass process. Security control should be tested during incident simulations, not treated as documentation. In your answer, cover least privilege, identity federation, short-lived credentials, secrets management, audit logs, tenant isolation, network controls, break glass access, supply chain security, and security incident response. Question 16. How would you distinguish a real incident from an alerting problem? I would compare the alert with user-facing indicators such as successful requests, latency, deployment completion, and regional availability. A single host metric may be harmless, whereas correlated error budget burn confirms impact. Alerts should have clear owners, severity, runbooks, and actionable thresholds. I would review false positives, alert fatigue, and missed incidents after every major event. Suppression is appropriate during known maintenance, but it must expire automatically and never hide independent customer impacting symptoms. Discuss symptom-based alerts, customer impact, corroborating signals, alert quality, burn rate thresholds, deduplication, severity, suppression, and measuring false positives and missed incidents. Question 17. What would a strong postmortem for a Vercel outage contain? A strong postmortem explains customer impact in measurable terms, including duration, regions, products, and affected workflows. It provides a precise timeline from change to detection, mitigation, and recovery, then separates trigger from contributing conditions such as weak safeguards or unclear ownership. I would document what worked and what failed without assigning personal blame. Every corrective action needs an owner, priority, and deadline, and follow-up reviews should verify that controls actually improved reliability. Make sure to include impact, timeline, detection, contributing factors, technical and organizational causes, mitigation, what went well, action items with owners, and blameless language. Question 18. How would you test the reliability of a new Vercel Edge feature before broad release? I would test correctness first, then exercise regional routing, latency, concurrency, dependency failures, malformed inputs, and partial network loss. A small canary cohort would receive the feature behind a flag, with synthetic checks and dashboards for both technical and customer outcomes. I would define rollout gates before testing, including error rate, tail latency, and support signals. Rollback must be rehearsed, not theoretical. I would expand gradually only when evidence remains healthy across realistic failure modes. Cover unit and integration testing, regional testing, load and fault injection, canaries, synthetic monitoring, rollback readiness, dependency behavior, privacy checks, and explicit exit criteria. Question 19. How would you design reliable asynchronous workflows for builds, deployments, or background tasks? I would place work on a durable queue and give every task an idempotency key, because workers can crash after completing an operation but before acknowledging it. Retries should be bounded and use backoff. Poison messages belong in a dead letter queue with operator tooling. Visibility timeouts must exceed normal execution while allowing recovery. I would expose progress and cancellation, enforce backpressure, and monitor queue age, not only queue depth. Exactly once behavior is usually achieved through idempotent effects. Discuss durable queues, idempotency, retries, dead letter handling, deduplication, ordering, visibility timeouts, progress tracking, cancellation, backpressure, and recovery after worker failure. Question 20. Tell me about a reliability improvement you would prioritize during your first months as a Vercel SRE. I would begin by learning the service architecture, on-call history, SLOs, deployment flow, and highest impact customer journeys. I would analyze incident and ticket data to find a repeated failure mode, then validate it with engineers and support teams. My first project would target measurable leverage, such as reducing noisy alerts or improving rollback safety. I would ship a small mitigation quickly, define longer-term fixes, and report outcomes using recovery time, incident frequency, and error budget improvement. Be sure to mention learning the architecture, validating customer impact, choosing measurable leverage, partnering with developers, creating a roadmap, and balancing immediate mitigation with durable engineering improvements. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.